Now we are in problem 8 of homework 7. So this question is about the Poisson process, and we have several properties in this problem. So in the first question, we need to find the expected value of a stochastic process of x. X is a random variable, and from the past lecture, we know that the probability of Poisson process should be like this, and we also know the expected value of the Poisson process should be lambda. It's a standard form of the Poisson process. So the expected value, the mean should be lambda. It's for a single random variable, and for the stochastic process, the expected value of xt should be lambda t. Because we from the properties we know that at a time moment t there is no more one Poisson point. So we form the stochastic process xt equals to m and 0 to t. So the expected value, the mean of the stochastic process should be lambda multiples t. So that's the first question. And in the second question, we know we need to find the autocorrelation. So T1, T2. So just put the use the standard formula of the autocorrelation. We got it should be equals to the mean of xt1 multiples xt2, and so now in this we need to do some change. We need to transmit it, and we transmit this into this xt2 should be equals to xt2 minus xt1 and plus xt1. Just put these two elements into this, and so just do some calculations, and we got this. The mean of xt1 multiples the xt2 minus xt1 and plus the mean of the square of xt1. So because the so from this formula, from this equation, we need to calculate the value of x, the mean of xt, the square of xt1. So we need to do some transmission. We know that the expected value of x, the square of x, should be like this, and from this, from the mean of x, the random variable, when we got this, and transmit this to this, and finally we got the expected value of the square of x should be like this, lambda plus the square of lambda. And also, from the properties, we know that all of the random variables n t1 t2 or n t3 t4 and so on are independent. So we can just put this the value of the expected value of xt1 and multiples directly to this, the xt2 minus xt1, and we put this t1 t2 into this, the lambda t. So we got this. The auto correlation should be like this, but this result should only for t2 when t2 is more than t1, because we have assumed that t2 is more than t1, larger than t1. So in this form, the xt2 is xt2 minus xt1. So in this condition, the result should be lambda t1 multiples 1 plus lambda t2. But if t1 is more than T2, so just converge them, and the result should be lambda T2 multiples 1 plus lambda T1. This is for for the condition when T1 is more than T2. So it has two kinds of result in the second question. So that's the whole things of the problem 8.